So, again, I was not talking to you guys about the opting out versus not opting out on testing. I just want, I'm a person that I always like, give me all of the facts, because unfortunately there's too much out there that isn't true. So, if you opt out of testing, does that prevent you from going to college? No. I just want to give you guys the opportunity to understand if you chose to, that might be
increasing your chances.
There might be other things. Oh, okay, thank you.
Is that for me?
Nope, John. So, like if I'm gonna stay, here's one. Let's make it fun. If I'm going to go to Disneyland or Disney World, and I don't care which one's your favorite, and if you've been there or not, but just be honest with me on the price. And what does my price give me? I don't like to be surprised by, oh, I didn't realize that. And I don't want someone to say, oh, well, you didn't read the small print, because you know what? Yes, the small print is there because that's a legal document, but if it's that important, don't make the small print, make it known to people. Okay? So I want all of you, just throughout life, to make informed decisions and not decisions based on, what your friends might have said, things like that. You are your own person. You really are, which is fantastic. That's what you want to be. So make your decisions based on what you're all about. Don't make it based on what you think others should do. Okay? Hey, was there any questions from our worksheet? Any questions? Anyone tough? Can I see it real quick?
You covered 13.
13, yeah. So I'd say 1, 2, 3, 4, 5, and 6. If you were just to pick two of those points and find the slope, it should be the same slope throughout. Okay, because if they are linear, it doesn't matter what 2 points you pick, whether it's the first and the third, or first and the second, or if you pick the fifth and the first, something like that, you will get the exact same slope, that's how linear equations should work. A linear equation has the same pitch to it no matter where you are. You said 13?
Yeah.
Oh, it's a story problem. That should be good. Always has a good ending. Okay. Story problem. A local service center advertises that it charges a flat fee of $50 plus $8 per mile to tow a vehicle. Okay, and then they say that they're using functional notation using C in this case because it's going to represent cost. And they're going to say 8x plus 50. Okay? So, what the $50 means is if you call that company and say, hey, I need a tow, there's $50 is a flat rate, and then they're going to start charging you $8 for every mile that your car has to be towed. Okay, represents C in cost in towing a vehicle, where X is the number of miles a vehicle is towed to identify the slope and the Y-intercept. Okay, so this is the slope, and this is the Y-intercept, which we know as B, which could be the point 0, 50. So if you were to talk about the slope in the context of this problem, the slope in the context of this problem means that for every mile towed, $8 is charged to you. Okay? So if you were towed 2 miles, that's $16, but you have to pay the 50 on top of that, so you're paying $66. If you need to be towed 10 miles, that's $80 plus the 50 that's in there. Okay? That make sense? So, and then reading things in the context of the problem is also important. Science does that a lot for you as well. Okay. Could the slope be put over 1? Sure. Because if you were graphing, you'd go up 8, right 1, up 8, right 1. Make sense? Is there any other questions from that? It was pretty short, I thought. And I-
Short.
Huh?
How is it pretty short? It took me 45 minutes.
Really?
Yes. I
The
was really
first
slow.
6 took like 10.
Did you find the slope just using 2 of the points, or did you keep finding the slope over and over and over again? Okay. Gosh. Well, I hope you get a little quicker at it, because if not, you're going to spend a lot more time. You don't focus? Okay. It happens. Is there any other questions you need me to go over from the worksheet? Okay, make sure your name is on it, please. Pass it on forward. And if you're handing anything old in, also pass that forward, please. No coughing in here, Missy. Just saying. But it's kind of frustrating going, well, if you can't learn from my videos, then don't miss school. Right? I might be off base on this one, but it might be close. You what's that? Don't you ever threaten me like that again, buddy. I'm just kidding. That's an old liner that came out of a movie that was called Smokey and the Bandit. You know the movie? When Junior says to his dad, "Daddy, I ain't never leaving home." Don't you ever treat me like that, boy. All right. Let's go to these. All right, graphing linear functions, number 7. Equations in point slope form. Okay, learning target, I can write an equation in point slope form. Okay, so a few things that let's review. If I have this is called standard form. And if you were using this, if you were graphing using this, you use the cover method to find x and y axes crossings, right? We talked about that. Remember that? Yeah? Yes. That's sweet. And then we learned a little bit about if it's written like this. And this is called slope-intercept form. And I think it should be slope-intercept formula, but I think we were lazy when we were naming it. So, and this allows you to find where it crosses the y-axis, 0, b, and it allows you to use the slope as a map to find a second point. Agreed? And then we're going to get into one more that's called point slope. Point slope will, what we're going to get to today, looks like this. Looks like this. And this is the one that is actually used more often in later math classes and science classes when you're dealing with linear stuff. A lot of people like slope-intercept because that's how the calculators accept the information. Make sense? Calculators don't accept the information like this. They don't accept the information like this. Now they're starting to change their program so they will accept standard and point slope form, but as for the most part, the graphing calculators only accept y equals mx plus b or slope-intercept form. Okay? All right, so the warm-up. Find the slope between the 2 points. Well, we know that our slope equation is this, yes? And I'm going to label this x1, y1, and this x2, y2. A question, could I label this x2, y2, x1, y1?
Yes.
It'd be the same slope. So I just have to label it a certain way. So I'm going to get 4 minus minus 4 over 5 minus 3. What's 4 minus minus 4, Gentry? Adam, so it's 8, right? And then 5 minus 3 is 2. So my answer is 4 or 4 over 1, however you'd like to put it. Okay? And then if I had this, find the slope with these, I have x1, y1, x2, y2. And again, I could have labeled this x2, y2, x1, y1, but it's going to work the same way. So I get negative 5 minus negative 1 over 2 minus 6. Negative 5 plus 1 is negative 4 over negative 4, which is 1. Okay? And again, a lot of times you can write any number as a fraction by putting it over 1, and so that's going to give you the rise and run. Now, write the equation of a line in slope-intercept form. Well, this is slope-intercept form right here, right? I don't know what that really was. That's the form we want to write it in. Okay? So, we know m, and we know x1 and y1. Yeah.
So you could like graph this, maybe?
Could graph it. I like it. So you find the point, and then you find another point by using the slope. That could work. We do have that equation up here, and then I have this equation here. Gosh, I have m, I have x1, and I have y1. Any ideas? So I like the graphing idea.
Or you could just go back 1 point.
Try it with 1 point.
Just go back 1 point using the slope.
Oh, so find another.
Since
Try.
we're on the x, we're already.
Okay. So let's think about this. So I'm going to go a couple ways. So 1 comma 4 is here. And with that known, I could find the slope, and this is going to go up 2 and right 1. Is that okay? Okay, so that might be a way to do it. Let's see, what would happen if I were to plug into this equation? Let's see, I know m, so that's going to be 2. Do I know y2?
No.
So let's just leave that alone for right now. Do I know y1?
Yes.
And that stays minus, right? Do I know x2? Nope. Do I know x1?
1.
So what's kind of the problem there? I'm missing a couple of, okay? So things that we might do on this type of problem is say, okay, well, let's put this in parentheses and let's put this in parentheses. I don't know if that's going to help us at all, but let's do it. And then maybe I'm going to take, just kind of thinking, what would happen if I multiply both sides by this? What happens with these?
Cancel out.
Cancel. Okay, let's extend the page a smidge. So that means that, let's clean this up. I'm going to have y2 minus 4 equals 2 times x2 minus 1. And I could probably get rid of the subscripts right now. So I'm going to do this. So I took the slope equation and I manipulated it. So this is the point slope form. The point, opposite, opposite, 1 comma 4, slope 2. Our original point was 1 comma 4 and slope 2. So point slope works when you have a point and a slope. Okay. But this one looks a little different. This has 2 points. So point slope works when we have a point and a slope. When I have 2 points, any ideas?
Just normal the slope equation.
Yeah, let's use the slope equation. We're starting to build into getting the equations. And I know that I should probably label this x1 and y1 and x2 and y2 and plug into our slope equation. And 6 minus 3, is that okay? What's 5 minus minus 1? 5 minus minus 1?
6.
6. 6 minus 3?
3.
What's my slope?
2 over 1.
2 over 1 or just 2? Agree? So now I have this. Hang on a sec. If I were to use this equation, which is the point slope equation, I'm now not going to label the x and the y. I have x1, y1, but I'm not going to have x2, y2. So my slope is 2. Agree? My x, I don't know. My y, I don't know. The minuses could stay minus. So I did label them x1, y1 up above. So what's x1?
3.
3. So this stays minus 3, right? The negative comes down. What is y1?
Negative 1.
Negative 1. So what is negative negative 1?
Y minus negative 1.
Which is?
Y minus minus 1.
Which is?
Y plus 1.
There you go. There's my equation in point slope form with 2 points. So sometimes if I'm given 2 points, I have to find the slope first and then use the point slope equation in order to modify it. Now, how would I solve that just for y? Subtract 1. You could distribute the 2 over if you wanted and then subtract 1 from that, and that's going to get you there.
Mr. Straub?
Yep.
Is there any way to find the y-intercept with the equation?
Solve it for y and just get rid of your parentheses. So what you're saying is this, and you're totally right. So this, I'm going to multiply here and here. Still with me? That's 2x minus 6, right? Now I'm going to subtract 1. Y-intercept is 0, negative 7. Okay? So this is point slope. We can modify point slope to find this slope-intercept. Slope-intercept finds us a y-intercept with the slope. Give the point 3, 4 with slope, slope 2. 3, 4, 1, 2, 3, 1, 2. Does that seem okay? Slope of 2. So from this point, I'm going to go up 2 and what? And to the right 1. Because remember, you can put anything over. So if I connect the dots, all we need to graph a line is 1 point and the slope. We discovered that yesterday, right? The day before? So point, if you need a point and a slope, any point and the slope. And again, the slope is a map to find a second point. So we can use the same information to write about the equation of a line. Okay, all I need is a point. So if I use my point slope equation, which is this, I'm going to label this x1 and y1, and let's plug it directly into this equation. Y minus y1
4.
minus 4 equals slope. What's my slope? 2. X minus what's x1? 3. So why are these signs staying minus when I plug positives in? Because they are minus here, so they have to go minuses there. Okay? And this is where a graph starts shifting around a little bit. So that's your point slope form of a linear equation. So the y1 is your y coordinate, your x1 is your x coordinate, and your slope is just your slope, or your map to your second point. Make sense so far? So let's see if we can try some. Write an equation whose slope is -3 that passes through the point -1, 7. So what should I label -1, 7? x1 and y1. And then this is my slope, so this is m. Wyatt. Y minus, what do you think? Here you go. My slope is -3, good. X minus minus 1. And what's x minus minus 1? Does it make it positive? Yeah. There's my equation. That's the equation of a line who has a slope of -3 and passes through the point 1, 7. Okay. Steve. X1, Y1 right here. You with me still? That's M. So Y minus -8, good. So that's going to become positive, agree? And then slope is what? 2/5. And then x minus 10. Only thing to modify? Let's make that a positive. So it's 2 negatives. So y plus 8 equals 2/5 quantity x minus 10. That's the equation that contains the point 10, -8 and has a slope of 2/5. Point slope's pretty easy to use. Point slope is the one that is the most accepted one to use in higher level math classes. Write an equation of a line with a slope of 6 and a point of 3, -7. Abby, what should I label this? X1, Y1, good. And this is, that's already given that. So ready, Y. Why is it +7? Yeah, because it would be y minus -7, so it would be y plus 7. Great. My slope is what? 6. Parentheses, x minus 3. Done. That's the equation that contains the point 3, -7, and also has a slope of 6. Seem tough? Seem a little straightforward? Doable? All right, so write the equation with the slope that passes through 1/2, with slope of 1/2 that passes through the point 4, -3 in point slope form, and then change it to slope-intercept form. Okay? Yeah, we're going to have to get y by itself, so we'll distribute, okay? So Gentry, what should I label this? X1 and Y1, and this is what letter? M? Cool, so let's do this. Y minus -3, agree? Yes. Which is y plus 3, equals slope 1/2 times x minus, okay? So that's my point slope form. If I wanted to make it slope-intercept form, to solve for y, I'm going to do a couple things. I'm going to distribute here and here. That's going to give me y plus 3. What's 1/2 times x? 1/2 x. What's 1/2 times -4? 2. Is that okay so far? Is there any part of that that's not mixing yet? Mr. Stacks, I want to get y all by itself, so what should I do? Subtract 3, I like it. Okay, so if I subtract 3, I get y equals, I get 1/2 x, and what's my last number going to be? -5. Rom, where does this cross the y-axis? at 0, comma, negative 5. But it crosses at negative 5, you're absolutely right, but the point 0, negative 5 is the point. So, point slope form, very important for us. We can easily make it in slope-intercept form. Make sense? Seem okay? All right, last one. Number 5. Write the equation so that the line goes through 2, comma 1, 4, comma 5 in point slope form, and then change it to slope-intercept form. What am I missing up here that I've been dealing with? Slope. I don't know what slope is, so I bet you we need to throw the slope equation in here. Right? And I'm going to label this. I'm going to label this x1, y1 and x2, y2. Agree? Make sense? So I'm going to go slope is 5 minus 1 over 4 minus 2, which gives me this. 4 over 2, which is 2 over 1, or we'll just keep it as 2 for right now. Is that okay? Now I want to show you all one thing, so put your pencils down for a second. I want you to see something real quick. I'm going to do this. What did I just do? I flip-flopped it. So that's going to make it different. So watch this. So I'm going to go y2, 1 minus 5 over 2 minus 4. And that's going to give me negative 4 over negative 2. Negative over negative is what? Positive. So this gives me m equals 2. Okay? And I did that for a reason. I wanted you just to see that for a second. What do you got?
Okay, so do we need to simplify it? Because even if we like do it in negative 4 and negative 2, we're going to get the same slope.
Yes.
So for the test, if we don't simplify, is it fine?
You want to leave it as 4 over 2?
Yeah.
Okay.
We forget.
Got it. I don't think a reducing is a major error at this point. All right, so I want to show you something. Okay? So I'm going to do this one in blue. So I'm using the black points. Okay? So y minus, use the black. What's y1 in the black?
1.
1 equals, our slope is what?
2.
X minus 2. Hang on a sec. Take a look up here. I'm going to now do this one, same slope, but I'm going to use the red ones. Ready? Y minus, use the red ones.
5.
Y minus 5 equals, slope is 2, x minus 4. Take a look at these two equations. Do they look the same? They're completely different numbers, agree?
Yes.
Does everyone see that?
Yes.
So one of the equations is y minus 1 equals 2 times x minus 2. And the other one is y minus 5 equals 2 x minus 4. Does everyone agree that those are completely different looking answers? Does anyone like, dude, they are identical? So watch this. I'm going to take both of these. I'm going to use both of these, and I'll use green for both, and I want to get them both y equals. So on this one, I'm going to distribute 2 over. Still with me? And then I would add 1.
Y equals 2x minus 5 or minus 2.
Okay, so is that what that look like that over there? So my y-intercept across is at negative 3, so 0, negative 3 with a slope of 2. Okay, I'm going to do the same thing here. I'm going to distribute here and here. Agree? Add 5.
Y equals 2x minus 2.
So there's possibly 2 different point slope equations from every set of 2 points. But if we were to solve for y, we get the identical same answer. So if I ask you to put something in point slope form, do you think I realize that there's 2 answers? And I'm not looking for both. But some of you see things a little different. Some see the way we have this written in the black. Some see how it's written in the red. Cool? Look at that. It's the same answer both ways. It happens like that on purpose. Okay? Is that the last one? We're done? Are you kidding me? All right. What do we got here? Let's do worksheet number 7. Which is only page 83. Hey. Sound good? Now, we don't have class tomorrow, right? Because we have the testing day thing. Dandy. So this will be due on what day then?
Friday.
Sweet? Make sense? Did I do okay?
Where's West?
If you want to walk down the hall and see, check.